So here we have a velocity of the hurricane, 180 kilometers per hour, and we can immediately convert, and we can say 1,000 meters for every 1 kilometer, and then we can say 1 hour for every 3,600 seconds. And this is going to give us 50.0 meters per second. And then for the area of the window, we have 2 meters by 3 meters. And pressure inside of the window essentially will be 1 atmosphere. So when we do this, we're going to have to say, okay, apply Bernoulli's equation. At inside, outside the window. And so we're going to say that P inside plus half rho V inside squared plus rho Gy inside is going to equal P outside plus 1 over 2 PV outside squared, rather rho V outside squared plus rho Gy outside. So we can assume that Y inside equals Y outside. So the height difference between the outside and the inside of the window is going to be 0 rather. So we can say that these two terms cancel, and then we know that we can say that the velocity on the inside is going to be equal to 0 meters per second. So we can also eliminate this term. And we finally have that P inside minus P outside, which in this case would be the pressure difference, would equal 1/2 rho V outside squared. So at this point, we can then solve and say that, let's keep the variables for now and say that this pressure, this change in pressure, is equal to a force divided by an area, because this force divided by an area is the definition for pressure. So if we say this, we can say that the force is going to be equal to 1 over 2a rho V outside squared. And once we have that, we can then solve. So F is going to equal 1 over 2, and then the area will be 2 meters by 3 meters. And then the density of air will be 1.29 kilograms per cubic meter. And then we have 50 meters per second squared. And this is going to equal 9675 newtons. And we can round off to 2 significant figures and just say 9,700 newtons. So this would equal the pressure difference from on the outside of the window from the inside of the window. And that's the end of the solution. Thank you for watching.